Again, we are here to continue with the part two of the data transformation. Subject machine learning topic is data transformation. In the previous video, we have studied some few steps smoothly enough. We'll be continuing with that. The fifth point of data transformation part is generalization. It converts low-level data attributes to high-level data attributes using concept hierarchy. For example, age initially in numerical form 22-25 is converted into categorical value like young and old. For example, categorical attributes such as house addresses may be generalized to higher level definitions such as town or country. Here, as the term says generalization, we are converting the low level data attributes to high level data attributes using a concept of hierarchy. Like we have the numerical values of 25. We have taken it as the categories of young and old. Similarly, we can go ahead with the category attributes such as house address, and which is again generalized with the definition of the state, then further the state into country, and finally the continent, and so on. So this was the method of generalization. Coming towards sixth point, which is normalization. The data normalization involves converting all data variables into a given range. Techniques that are used for normalization are min-max normalization. Set score normalization, decimal scaling. So we will be doing this min-max decimal scaling and z-score normalization one by one along with the examples. Did you get an idea? What do you mean by normalization? Basically, when we get the data, so it happens that the data is required to scale according to our need. For example, I'll give you an example that you all have gone through. You all must have seen the map in your Atlas book, right? And there, for every 1 unit, they do it like every 1 unit is equal to 1 kilometers, because if they start mapping exact 1 kilometer, the map would be very vast one, and that won't be concise in Atlas, right? So they have normalized that by containing that unit is equal to 1 kilometers. So similar thing happens when we normalize the data, we are converting all the data variables into a given range. So the method is min-max normalization. This is the first method that we are dealing with. This transforms the original data linearly. Okay. Suppose that min A is the minima and max A is the maximum of an attribute P. So there is the formula. Sorry, this is little blurred. That had blurred. V dash is equal to V minus min P upon max P minus min P. Within the brackets, mu max P minus mu min P plus mu min P, where P is the value you want to plot in the new range, and V dash is the new value you get after normalizing the old value. Let us understand this with an example. Suppose the minimum and maximum value for an attribute profit P are 10,000 and 100,000. We want to plot the profit in the range 0. Using min-max normalization, the values of 20,000 for attribute profit can be plotted to 20,000 minus 10,000, which is the minimum, upon the maximum value, which is again 100,000 minus the 10,000, and in within the bracket 1 minus 0 plus 0, which is 1 minus 0 is new max p minus new min p, which were the range 0 and 1, plus new min p. So new min p is again 0. So after solving this, we get the value 0.11. So hence we get the value of b dash as 0.11. That means the value of 20,000. If we want to plot that between 0 and 1, the value will be 0.11. So this is how we have normalized the value of 20,000 with the help of min-max normalization. Coming towards the Z-score normalization. In Z-score normalization, or it is also known as zero mean normalization, the values of an attribute A are normalized based on the mean of A and its standard deviation. You all know what is mean. You all know what is how to find standard deviation. So the formula is a value V of attribute A is normalized to V dash by computing V dash is equal to V minus A upon the standard deviation of A. Let us see this with an example. Let the mean of an attribute P is 60,000. The standard deviation of P is given as 10,000 for the attribute P. Using Z-score normalization, a value of 85,000 has to be transformed. What will be its value? So again, what we have done, 85 is the value which we need to transform. So that minus the mean upon the standard deviation. So 85,000 minus 60,000 upon 10,000. That is equal to 2.50. So hence we get the value of V dash to be 2.5. I hope you understood this Z-score normalization. Now the last is decimal scaling. It normalizes the values of an attribute by changing the position of the decimal points. The number of points by which the decimal point is moved can be determined by the absolute maximum value of attribute A. A value V of attribute A is normalized to V dash by computing V dash is equal to V upon 10 to the power j, which is the smallest integer such that max V dash is less than 1. Okay, again, let us study this with an example. Suppose the values of an attribute P varies from minus 99 to 90. So the maximum absolute value of P is 90. For normalizing the values, we divide the numbers by 100. That is, j is equal to, or the number of integers in the largest number, so that the values comes out to be 0.98, 0.97, and so on. Again, I repeat, by normalizing the values, we divide the numbers by 100. J is equal to 2 because 100 have 2 zeros. And the number of integers in the largest number, so that the values comes out. So this is how we find the set normalization.